I'm Andy, and I'm in San Jose at the Compound AI Systems Conference. We rented an abandoned steakhouse filled with the ghosts of Morton and other dead steakhouse founders. That's not who you hear in the background, though. Those are my friends who are the leaders in AI, and we're going to put microphones in front of them and ask them questions about the power dynamics of open versus closed, where the frontier in AI is headed, and let's go ahead and get our first researcher and put a microphone in their hands. Thanks, Matei Zaharia and Heather Miller, for joining me here at Laudecast. Matei, you're a co-creator of Databricks, and you're a professor at Berkeley, previously Stanford and MIT. You created Apache Spark as a PhD student. Heather, you're a professor at Carnegie Mellon right now. You were advised by Martin Odersky and were a key contributor to the Scala programming language. You're also doing a startup in addition to your current professor job, and that's in the space of compound AI systems. Is that right?
Correct, yep.
Cool. And you are both co-chairs of this conference, right?
Yep.
Both of you are big champions and cornerstone stewards of the compound AI systems community, which we've convened today here at an abandoned steakhouse haunted by the soul of Morton himself, who we don't know. His soul can still haunt things even if he's alive, I'm pretty sure. My soul is haunting 3 steakhouses right now while interviewing you.
Wow.
Okay, let's talk briefly about compound AI systems. How do you pronounce it, first of all?
Oh, the name of the conference?
Yeah, well, they're acronym.
I've been saying CAIS, but
CAIS.
Everybody says different things.
I want to say CAIS, but my brain keeps saying case. Okay, so what makes this conference different? This is the first run of it.
Yeah, the point was to bring the researchers together for this new field. And I think what's really cool with this conference that like Heather and the PC did is they actually got great reviewers from many fields.
Yeah, so the composition of the selection committee was intersectional.
Yes.
Across the various subcomponents in the compound systems ecosystem.
Yeah, exactly.
A thing I'm spending a lot of time thinking about is the community as a whole that champions and works on open research in the context of AI has a new set of ecosystem and economic dynamics that it exists within that I think new compared to previous technology paradigms like the one we built Databricks around, like big data, cloud computing. And one of the big differences in AI is the amount of resources required and the resources available in industry versus the scarcity of resources in academia and not just academia, but anybody trying to do open research, since so much industry research has become closed research. Is there something that like a Gestalt property or some sum is greater than the parts that the open ecosystem and researchers working on different parts of the compound system as we interpreted at this conference can lean into more to like keep open at fighting weight with the closed labs where they're so much better resourced right now? Is that a part of the theme that you think about organizing this conference?
I mean, I was looking to you for guidance on how to...
I'm looking to you, so we have an infinite loop now.
Yeah, no, Matei, break it.
I think we have ideas on both sides.
Actually, the whole Berkeley Skylab, I mean, like, the Patterson lab style of having a lot of people work together on kind of larger, more impactful projects together. I mean, that's kind of a step in the right direction, honestly, right? I think that we should be doing more of that.
Yeah. I think it would be cool to get some cross-institution efforts like that going. There aren't too many in computer science, but it's starting to happen, I think. So, for example, like Open Thoughts, this data set of like thinking traces that you can use to train models ended up with a lot of authors on it from different places. I can imagine more things like that. There's another example of a pretty academic field where this happens, where experiments are expensive, which is like physics or the physics experiments, right? You build like the Large Hadron Collider. It's a huge project. Then you do these experiments and you end up with a paper with like 1,000 people on it or something.
Yeah, I think an observation about the Hadron Collider is it's infrastructure that serves as a platform for researchers who have independent research hypotheses to go explore, test, and have access to the shared infrastructure, a commons infrastructure.
That's right.
Heather, you have tried some creative forms of fundraising that I was involved in. Describe in brief how you've approached fundraising at the intersection of startup land and academia.
At the moment, there's a lot of interest and many things happening and taking off. And there's no shortage of interest in academia. In fact, everyone is panicking because the NSF has basically been kneecapped. And so let's just match up the two.
Match up the two things, which are
the desire for, research transferring quickly
to industry, to
in
impact, to
yeah.
product.
Right. So, VCs and early stage companies typically are trying to pull something out of academia and then build a product on it, right? That is a strong desire. And then there's a strong desire to do that kind of work. Academics want to be relevant, right? And so it's just like bring these two things together.
And you have done that? You've brought
Yes.
them together?
We have this model where hopefully we can use investment for a startup to fund research that's relevant to a startup, right? It's trying to bring them closer together and put people in the same room.
So when you fundraised for your startup, you said we want to earmark a certain amount of the seed or pre-seed round that'll just go straight to fund PhD students that are working who downstream of their research to startup will productize it.
Yes, correct.
Kind of like align all the incentives at the intersection
100%,
of the open research and the tech transfer to product.
Go to the researchers that build things, build things in the open and want to see these things take off. The point is it's a cross-university thing. Hey, maybe, finally we get some of these cross-university efforts off the ground.
Yeah.
Cool.
Oh, no, it's Andy Pavlo.
People banging on the window. Hi. Cool. Okay, last thing. If there's one outcome that you would like to see happen from this conference that you're co-chairing and organized, what would it be?
I think it's people in different fields talking. I'm already seeing it, but yeah, I'm excited to catch up with everyone and see the next, wave of ideas that come out of this.
I want to see people, submitting next year's papers together.
Collaboration.
Yeah.
It's not just like
output.
collaborations for hippy-dippy feelings, but it's like, again, you can only carry the weight so far by yourself.
Yeah, we need the sum is greater than the parts.
Yes, 100%.
Great. Okay, well, thank you for chatting. Yeah, and thanks for organizing the conference.
Thanks.
Thank you.
Very cool. What are we going to talk about?
Whatever you want. Talk about research directions, optimism, pessimism for the field. It'll be fun.
Okay. Joey Gonzalez, thank you for chatting with me at Laudecast. You're a professor at Berkeley. You did a postdoc at Berkeley, same time
right.
that I was finishing my PhD there. You've done some startup work and multiple startups. Graph Lab, and more recently, Letta,
Run LLM.
Run LLM. Yep. You're intersectional. You're passionate about technology research and transfer of that into startups.
Yeah, I work on the kind of intersection of AI systems. Actually, this conference is kind of a neat place, bringing agentic systems and AI and the ACM and the systems community together. And it's a neat story how systems and AI, separate fields, as they came together, this idea of scaling became a central theme of that mission. My thesis work and Matei and others in that time period were, how do we take machine learning and not just make the models better, but bigger? How do we access more data? And would scale unlock new capabilities? And it turns out scale did play a pretty big role in unlocking new capabilities. And so that kind of fusion of fields of different minds coming together, systems people, engineering mindsets, data mindsets, and statistical modeling mindsets that made AI systems and really made the modern era of AI.
How do you see what's playing out now in the kind of landscape from open research and closed research going? And are you worried, or do you think everything's copacetic?
This is a hot topic, a concerning topic for me. Where is open research going? Where is closed research going? It's crazy that 5-6 years ago, OpenAI was an open thing, and like open meant something. We're in a really scary and exciting time. So research is going much faster. A single grad student can do way more. And so there's a lot of opportunity for us to innovate, to not just climb the hills that we have, but to invent new hills to climb, which is awesome. But at the same time, the great students that are doing really cool stuff are getting plucked out of the PhD programs and pulled into these labs, offered comical amounts of money that I can't compete with as a professor. And I think there's a real risk.
We're talking like multiple $1 million per year in equity.
Millions of dollars per year, yeah. And I think there's a real risk that the next generation of innovators, of thinkers, won't exist because either they got pulled out of grad school or they won't even go into CS or into AI research. And I think there's so much opportunity for graduate students, for computer scientists to shape what AI is for all of us. And it would be a shame if that was just pulled into a small set of organizations.
Yeah, I've often thought about the risk in terms of the PhDs who would have likely stayed in academia and created the next generation of faculty that would mentor the subsequent generation. There was this recursive dynamic in academia because the core program is advisor-advisee. So you have a close partnership, and the gist or the main reason to do it is to train up the next generation. And it turns out that the best way to train them to be as luminary as the current generation is to work on research. Like, you're actually learning a vocation, which is to be one of the world's best researchers. And the best way to do it is to spend 5 years glued at the hip to one of the world's best researchers. And the big labs they don't have that mechanism. So I've thought of that as the main risk, because they break this recursive loop that we've had for millennia. But you're also pointing out another risk vector, which is the discouragement of the generation below that coming into undergrad and halfway through the undergrad, dropping out of CS and not even getting to the PhD program or even through computer science as an undergrad.
I want to emphasize, this is a very important point. We got to where we are today, not just because of great academic research, but because of that collaboration between industry, between academia, OpenAI being open, Google Research being open. It inspired the next generation of graduate students, maybe the next generation of undergrads, to go into this field. That excitement, that energy is critical to the future of our field. We can't just hand that off to AI. And I think I'm very worried that we're quickly moving to a situation where that excitement is lost.
So what are you doing about it?
Yeah, so what am I doing about it? So I'm still in academia. I haven't left my job. I'm trying
that's one thing.
Yeah, it's one thing. I'm trying to encourage graduate students to take that risk, to bet on themselves, to be able to be the pioneers that will take us where we need to go next. Part of that is picking research agendas that aren't just climbing the hill that the billions of dollars are racing to the top of, but finding new hills, anticipating where the field's going. I think for my career, if I look back at each point in my career, I basically assumed I would lose at the thing everyone was doing. So when I started my PhD, everyone's building models. I go, you know what? I can't build models as well as them, but maybe I can scale them. So once they have good models, I'll scale them. As I started as faculty, I was like, you know what? I can't scale models as well as Google, as Facebook, Meta at that point. But maybe I can serve them, because once they build really big models, the next problem will be, how do we use those models? And so I went inference. And now what comes next? I think maybe what comes next is the challenges that AI will create for the world around it. So one of those challenges is the systems we build need to be able to handle this new workforce of very capable agents that can do far more, far faster than a human. And so I think there's a real opportunity to rethink the software systems we built that were designed to serve humans to now serve AI more efficiently, more effectively.
What's a specific example?
So a great example, take a database. We're at an ACM conference. A database today is designed to take queries from a human or maybe from a very simple dashboard. But you could ask an agent, hey, solve my business problem, and it can ask thousands of queries per agent, and then have thousands of agents working against that database. They'll ask harder queries, more complex queries. But the database doesn't have to answer those queries. It can say no. And this is a new era for how we build systems, that the system doesn't have to be as forgiving, as friendly as it would be to a human. It can say, here are 1,000 other queries that I can process more efficiently. Can you rank them and choose your favorite? And I think that'll be critical to making our world more effective and more adapt to what AI can do and what it can offer.
And your sense is that the big closed AI labs aren't focused on this right now. This is sort of your call for where the puck's going.
The big labs should be and need to be focused on really advancing what their AIs can do. And in many ways, that's adapting to the world as it is today.
Exactly.
But I think we, as research, have an opportunity to think what the world could be tomorrow to make that more effective. And I think maybe the more important part of that is to figure out our place in that world. And so as we scale systems, as we scale AI, the remaining thing that doesn't scale is us. And I think our ability to communicate, to command these new forces is something we can be studying today in academia.
I'm curious, you said that you're advocating to your students about the advantages of staying. And I'm curious, how well is that resonating? Are there other edges or advantages that resonate with a young generation of PhDs?
I think when I look at the next generation of grad students, one thing I see more excitement around is being involved in policy and shaping what that world looks like that they will inherit and how they will adapt the technology and the ideas around it to influence that world.
Yeah, great. Cool. Okay, we'll call it there. Thanks so much. Have you done a podcast before?
Yeah, once. Yeah, for a Greek newspaper, I did a podcast.
Okay. On a scale of 1 to 10, how would you rate that podcast interviewer?
No, I think it went very well. I don't know, 8.
Really
9.
well.
Yeah,
8.
yeah,
Okay, that's
yeah,
the score to beat.
Yeah, well, okay. Good.
Ioannis, thank you for joining me to chat about ACM, about this conference, about your background and the current state we find ourselves in data and AI. You're a professor at University of Athens, and you're the president of ACM right now.
Correct.
So the Association for Computing Machinery, that's what ACM stands for, as your sweatshirt says.
I talk the talk, I wear the wear. So.
Yeah, no, I need to get one of those. It also says open by design. Tell me more about open by design.
As of January 1st, 2026, the ACM Digital Library is fully openly available to everyone from anywhere without having to pay.
Wow. That's huge.
And that was something that we started a path in 2020, and through changing our business model around it, because open, yes, it means free at the point of use, but still there's a cost in publishing. So we changed the business model. We have more than 3,000 institutions around the world now that they subscribe not for reading, but for publishing.
Wow.
And so now everyone, whether they are rich or poor in Antarctica or in Mars or in Stanford, they can read all the papers. It's a democratic way for publicly funded research to be openly available to society and, of course, all the scientists. So that's what we're after.
Yeah, ACM is one of the most foundational institutions in computing, and it's got impact and influence across all of kind of the main fields of computing. And it sounds like that was a move that updated and kept ACM at the bleeding edge on a key pillar, openness. Do you envision other foundational shifts in the way ACM organizes as a reaction to how AI is changing the world around us?
Well, in every group, in every pillar within ACM, the discussion is how AI is influencing this. How is AI influencing education? And how are we going to teach computer science? Or how AI is influencing education in general? And how is industry changing with the use of AI? Is AI influencing all the issues of diversity, the haves and the have-nots? So issues like inequalities and fairness are at the middle of what we're looking for. And
open as a pillar, democratizing access to the knowledge.
Openness is one big piece of this puzzle.
Do you think that the amount of funding that researchers need to get, the amount of pay being so much smaller in academia and open research, whether it's at a lab or not, is a new type of threat and a worrisome threat? Do you have thoughts on that?
Openness, I don't think it brings any threats. Other aspects are more threatening and more worrisome. For example, the reduction of funding that goes into universities and labs. The funding that is on chips or on AI and so on, I think remains high. But and I'm not talking about just the US. Also, I see it elsewhere as well. But for basic research, curiosity-based research, funding seems to be being reduced. And that is worrisome because, Dave Patterson was here. His research, had an idea. It was driven by something, but it was not a particular need for a particular application. The US academic system was built by some pioneering thinking that we should invest in basic research. And many of the great things, Google, for example, came out of basic research and so on, and funding by NSF. So it is crucial that this funding is not reduced.
Do you have a call to action for people at the conference or people watching this, what we can do?
Talk to your congressman, talk to everyone, support NSF and its efforts, and not just NSF, NIH, all the funding agencies in the US.
I think a call to action that I've heard that echoes yours is that computer scientists now are more powerful than they've ever been.
True.
We are building technology that's changing society at rates and levels that are unprecedented. And still, our tendency is to speak to our people who know our language, our communities, and our fellow computer scientists when the world is starving for people like experts and people with power to speak truth about how the technology works and why the decisions are being made. And all they can do is tune in to Sam Altman and Greg Brockman and Elon Musk entering an Oakland courthouse or something like that.
I like you more and more.
And so how I think the call to action that I keep hearing and that I hear in your words is for computer scientists to go beyond just discovering and building and start leading and inspiring and speaking beyond the bounds of computer science to the world. And I think kind of like actually activating and actualizing the power they already have and maybe aren't feeling the weight on their shoulders as much as we need to be.
I agree with you completely. We have to step up, get out of our sandbox and our comfort zone. The impact that we have is tremendous. We are responsible to do that.
Great. Okay, well, thanks for taking the time to chat with us.
It was a great pleasure. Great pleasure.
That's it.
Good. Thank you.
What should we talk about?
I mean, you pick.
Well, at NeurIPS, we talked a lot about open versus closed. So we could do something different this time. We talk about Arena.
Can talk about Arena.
Okay, good. So Jan Stoica, thank you for joining me.
Thanks for having me, Andy.
Professor at Berkeley, co-founder of Databricks and Anyscale and Arena most recently, and other things. And one of the most prolific startup founders in top research right now. We go back to co-founding Databricks together, and you were a co-advisor of mine during PhD work. And you have been very active in your most recent company, Arena.
Yep.
Tell me about Arena. What does Arena do, and why are you excited about it?
So Arena, first of all, it comes from another Berkeley project, Chatbot Arena, which initially started as evaluating models for chat applications in the wild. You go there, you ask a question, you get answers from two randomized and anonymized large language models, and then you can vote which of the answers was better, where both are good or both are bad. And then you take this data, this user voting data, and you compute a leaderboard. Very similar like you compute leaderboard in chess using ELO rating. So that kind of has been very successful, and
all that was as a Berkeley project.
That was a Berkeley project. And then model providers wanted more and more to use this data to not only to evaluate their models, but to improve their models, right? So that's kind of what has been, and this is actually right now the main business model of Arena, and help model providers to improve their models. And it has been a wild ride. I think that one of the favorite stories is about Nano Banana, how the name came to be.
Oh.
And
I don't know this story.
Oh, you
this
don't
is
know
Google's
the story.
vision model, right?
So basically, Google evaluated and tested their models on Arena. And when you test a model which is unreleased, you give a code name, right, to be anonymous. And the code name for that model was Nano Banana. And now the users, kind of heard that there will be this kind of great model is going to come. And they came to Arena, and it was a huge jump in the traffic, huge. And everyone was talking about Nano Banana, how great it is and things like that. Now, Google, when they released, they came up with a name which is, Gemini kind of name.
Themed, marketing people.
But then people, when they released that, no one knew about what it is. They knew about Nano Banana. And in the end, Google
just
decided to use Nano Banana as a name of the product as well.
That's a good story. It hadn't occurred to me that there's a silver lining to the multi-sided network that Arena uses, which is it's like a structured way for leaks to build up marketing momentum and anticipation in the market for a new capability, because the public can see that a capability is coming and make guesses about which of the frontier labs is previewing it.
Actually, it's very fun, because if you think about what value we provide to our users is basically, you come there and you use real tasks. You have access to the most powerful models and you compare them and see which models works best for your task.
So like you're bringing your real problems as a user, you're using this thing as an alternative even to paying your $20 a month to whatever vendor.
You can see, okay, which model is performing best and so forth by comparing them and things like that. And indeed, this kind of is a value, and we see that actually a lot of users are coming with their, real problems, right? Like close to 15-20% math problems, and their science 6% is healthcare and life sciences problems.
Wow. And I have a problem in the world. I'm like at a company. I want to figure out which model to use.
Yes.
I can go look at. I can go run it in Arena and compare it to a bunch and see which.
But then it turns out that one of the main things that attracts users is exactly like you said. It's about trying to get their experience with a model which have not been released yet, right? So that's kind of became one of the unique value proposition, because where else you can go and try to play and test with the models you never they haven't released yet.
Nice, that's great. I hadn't thought of it.
It's like improving the model in terms of quality, reliability, and I think that the natural progression, it's really what excites me is to help developers and organizations to build reliable AI applications, right? There will be agentic application and so forth, and then reduce cost, right? These are the two things many people want, almost everyone wants.
Nice. Well, congratulations on being at the forefront of pioneering this model. So I hope others do it in much larger numbers, the same way you have been.
Thank you. Thanks for having me again.
Of course.
Okay.
Okay, and we have editing control, so it's like all free, easy conversation. Okay, Graham Newbig, thank you for joining me to chat here at CAIS conference. Thanks for coming to it. And you are a professor at Carnegie Mellon and also chief scientist at OpenHands, which is a startup that you're a co-founder of.
Yep.
And you're focused in both your research and your startup work on agentic applications of AI. What is OpenHands, and how's the company different than the open research agenda?
So OpenHands is a open source toolkit for agentic software development. We are one of the ones that's been around for longer, since March 2024. Some of the characteristics of it are that it's kind of language model agnostic, highly extensible. We have an SDK that's easy to use and plug into things. So a lot of people use it for both research, because it allows you to expand it, and for like incorporating it into products, because you can like rip parts out, swap them in, use whatever model you want, that sort of stuff. And then in terms of kind of my longer term research agenda, I'm working on coding agents or agents for software development now, because I view software as a way to achieve a lot of goals. So it's not just, writing software for software's sake, but it's writing software to solve problems. And, some of the problems I'm interested in are how to accelerate research, how to do automated science, how to help scientists with the tasks that they're doing.
And the hard sciences, like computational biology or physics or astronomy.
Yeah, I think having it be completely programmable would open up a lot of possibilities, and kind of like for software engineering, if we can automate away the boring parts, we can let people do the more creative parts. I think it will open up a lot of creativity in whatever space we apply it to as well.
Cool. And how do you feel about the state of open models, open weight models? Do we need better open models? Is it fine if we're all just kind of building a layer of advantage on top of proprietary kind of intelligence on tap?
I believe strongly that we need good open models. We need something that's competitive there. I think right now we're not there yet. We have something called the OpenHands Index, where we evaluate models on like 5 different benchmarks. And if you look at the diverse evaluations, you can see the closed models are kind of still, I wouldn't say head and shoulders above, but maybe head above, a lot of the open models. But I think, Also just having good general purpose open models is always very welcome. So anybody who is listening who wants to do that.
A big thing that we're focusing on with this conference and with Open Frontier is getting the various players in the evals plus data generation and recipes and pre-training and post-training and context optimization, agentic frameworks to talk to each other a bunch more and share the way you have with Marin, the roadmaps of the projects. If you're consumers, many people, you are a consumer of almost everything else in the stack, including data for model fine-tuning and context optimization. It feels like there's this sense that a Quinn or a Chemi or some of these large, extremely highly invested in open weight models are hard to dethrone. But if you pick a narrower lane, and the 7 researchers that are going to want to have for their use cases, for their research agenda, state-of-the-art performance, we could probably get some models to beat any of the frontier, even proprietary, if we just kind of stack the deck for our specific use cases first with much smaller weight models and some of these other techniques and then maybe expand one bowling pin at a time after that. Feels like the way to cheat a little instead of needing to build a model that just benchmarks and kind of wins at the broad suite of applications is just go straight to a scientist or 3 scientists that you want to use yours instead of Quinn. And if that's your objective, you start with 3, then we know how to turn 3 to 6 and 6 to 15. So does that resonate?
Yeah, definitely.
Okay, cool. I think you're already doing it.
Yeah. To some extent.
That's good. Well, great. I think that's it. So thanks for taking the time to chat.
Yeah, for sure.
Okay, Dawn Song, thank you for joining me. You're a professor at UC Berkeley, but you've also co-founded companies. You organize a summit that we're going to talk about. You wear many hats. What else did I miss?
And also I'm a co-director of the campus-wide center of Berkeley Center for Responsible Decentralized Intelligence as well.
Yeah.
Right.
And you are spinning companies out of that. So tell me about that center briefly.
Oh, okay, yes. So this is Berkeley Center for Responsible Decentralized Intelligence that works at the intersection of responsible innovation, decentralization, open source, and intelligence AI. Really, we want to push forward the frontier actually on responsible agentic AI. In some
and
sense,
decentralized.
Yes. Ultimately, I think we are going to have a lot of decentralized agents. I'm going to have my agents. You are going to have your agents. And
that's a grand vision. The trends are not necessarily lining up for that right now, though.
I know. So I think it's an important question to figure out what is the future is going to be like. Who is going to actually control such powerful technologies, and how much of individuals gets to control their agents. I actually talked about this even I think as early as more than even about 10 years ago, even with the last wave of deep learning. I mean, back then I was already thinking about personal assistance, how we actually can build this personal assistance. I call it almost like a fiduciary, is that you want to have personal assistant that's really working on the best interest of individuals instead of trying to maximize revenue of some, platform. And I view that it's particularly even more important as AI capabilities continue to increase and everything we do is going to be intermediated by AI, by agents, and so on. So we need some ways to actually really have AI to be on the side of the user.
The willingness of many people to give away privacy rights in order to get the advantages that come with an ad-driven model or just in general a walled garden approach to the internet has made me a little more cynical. What are the fundamental knobs that we turn, or levers that we use to actually make it play out so that agents have a fiduciary responsibility? And by fiduciary, I don't mean just financially, right? You also mean just like a moral obligation to defend and do right by the person.
Exactly.
Do you believe in your heart that there is just the right incentives that people will get it and they will choose an agent that has that versus an agent that seems that has mixed incentives, obviously, because of corporate overlords deciding that it needs to make them money?
Yes, that's a very good question. I do think, yes, this is actually a critical moment to actually think about these questions. Which road, which path the world, as a society, we are going to take. It's a different thing for what website you get to view and what message you get to view versus actually, what advice you get and
managing your finances actually at some point, literally, and also your relationship, like being a proxy in certain types of relationships.
Absolutely.
And how you manage your time.
So I would say, the stake is orders of magnitude higher. And I think hopefully users will care more about this. And also we hope that this will help incentivize even the big players.
How do you think about the way that you're influencing the direction of the way of the agent market or the agent landscape, especially now bringing in some of the stuff you've been working on recently, like the Agentic AI Summit and also Agent Beast? Is that what
Agent
it was?
Beats,
Yeah.
like a beat, like BAT.
Got it.
Yeah. So one thing I'm happy to share is we have this new agent evaluation paradigm called the AAA, Agentified Agent Assessment for open, standardized, reproducible agent evaluation. So basically, we make the agent evaluation itself an agent, and then this way it helps with the open, standardized agent evaluation.
That sounds great.
And then we did this Agent Beast competition. So we actually had many thousands of participants that participated globally from over like 130 countries.
Wow.
And over 800 universities and over 1,000 different companies.
Wow. So you bootstrap the evaluations. It's almost like building a benchmark, but you're building an agent that is a benchmark. And then phase 2, go see who wants to contend in that benchmark.
Yes.
Cool.
So then in the end, we yielded like hundreds of these judge agents and many hundreds of these subject agents. And the judge agents cover very broad domains, including coding agents, web agents, computer user agents, and also financial domain, game domain, legal domain, like very broad domains.
Sounds amazing.
That has been very exciting.
Congratulations.
Yes. And my dream is that in the future for like NeurIPS, iClear, if all the submissions can be done in this new paradigm, then all of them can be used together for us to really, continue to build out
Sure,
this,
the multi-agent future.
Right, multi-agent and generalist agent evaluation benchmark. That'll be
Cool.
That'll be
That's
super cool.
quite the vision.
Yes,
well, thanks
yeah.
for sharing. I think that wraps us for this slot, but I'll catch up with you tomorrow.
Great. Yeah, thank you. Thanks a lot.
Yeah,
Right.
thanks.
Yeah, thank you.
Okay, are we ready? All right, John Sad-Falcon, thanks for coming to chat. We're going to talk about Open Jarvis, but before we do, let's get you introduced. You're a PhD student at Stanford. You're working on a project called Open Jarvis, and tell me a little bit about the project.
Yeah, absolutely. Open Jarvis started with this just general sentiment that like so much of what we do with AI today could just be done on device. There's a huge amount of consumer devices available from Apple, NVIDIA, AMD. And while the cloud space and the cloud models are maturing and growing very rapidly, there's this underutilization of local compute and local models. And so we just wanted to see like how much of the current AI stack could be done on device. And so we proposed Open Jarvis. Name is obvious inspiration. And we wanted to basically see like what were the limitations of existing hardware, existing models, and just how much you could like push like these queries and these workflows to on device. And a surprising amount could just be moved on device. I think in a perfect world, everybody would want their AI to be in their pocket. At the rate at which local models are getting better, at the rate at which local hardware is getting better, we can imagine a very near future in which you have AGI in your pocket.
Oh, okay. The architecture is started there, and it's shifted to a little bit more of a generalization where you have these architectural blocks or elements that allow somebody to come in and specify the intelligence and make it keep the agent that's in your pocket pluggable, so that until we get kind of mythos level agents are actually running on my iPhone, I have the option to do some things locally, something to do with the proprietary cloud provider. Is that right?
Yeah, I think that's right. Like the way we imagine the AI stack is like local first, but like hybrid by design. Like I don't think everything will always be on device, but I think the vast majority of the things that you'll want could be possible on device eventually. Yeah. And you'll want it to be on device because it'll be free, it'll be private, it'll be completely owned by you.
With Open Jarvis users, do you see the population being mostly Apple devices or a spread?
I'd say there's definitely a majority of users who are on Apple devices, but we're seeing a lot of NVIDIA devices, a lot of AMD devices, even like a lot of like Google, like Android or Chromebook being used towards this. And I think that's really exciting because it just means like depending on the hardware available, depending on whatever's the best open source models available, you can pivot and move the whole AI stack very easily.
Makes a lot of sense.
Yeah.
The project has gotten a lot of adoption in the open source so far. Tell me about that. Like, can you give some stories of use cases that people are applying it to solve?
Yeah, absolutely. So some of the use cases that we've seen that have been like the most popular is just like all of these daily and like mundane tasks that like you just like want to run on device for privacy reasons, for cost reasons, for just speed reasons. People are using it, for daily messaging triage, for deep research queries, even for like different stuff around like code review or around just managing how they interact with coworkers or how they interact with their families. And so it's exciting to see all of these use cases that like some of which you envisioned, some of which you didn't. We're really excited to keep building systems that can help that span that gap between local and on-device intelligence and cloud intelligence. So we're building all sorts of collaboration techniques for that.
So where are you going to take it from here?
Yeah, I think from here we'd really like just making the whole experience as good as it can be, not just for like people who are tech savvy or like hobbyists, but people who just want to like have their first experience with AI that isn't just up in the cloud, but is actually AI that's on device, such that you actually own the model and actually own the whole stack, as opposed to always leasing your intelligence by paying to OpenAI or Google or Anthropic. That's the main direction we want to go, is just making it more and more accessible and more enjoyable. Right now, we're just focused on like building the community and building the research work around it. Down the line, who knows? But we're mostly excited to just keep making it better and better and keep studying a space that we think is going to be really important in coming years.
Well, congratulations on betting on that early. Cool. I think you got to go.
Yeah, I've got to head out, but this has been great chatting.
Yeah, thanks for taking the time.
Thank you so much.
Okay, Partha Sawa. Thanks for stopping by and chatting here at Laude Lounge at CAIS. You're a second year, just finished your second year in your PhD at Berkeley, and you recently launched Continual Learning Bench. So let's start with Continual Learning Bench.
Yeah. Wow, where should I start? I feel like this is just something that was kind of like a very obvious gaping hole in the discourse around continual learning. Maybe taking a step back as to like the motivation, like how I even got here. When I started my PhD, I think I was very interested in these problems around sample-efficient learning algorithms, or ways to update models after they've been trained, right? Like the way we train language models today, they're trained for months in these offline training processes kind of hidden in a box, and then we take them out of the box and we present them as a frozen topic to the real world. But a lot of people want to adapt language models. They want models that are learning online with their workflows, improving over time. And so I got really interested in this question, like, what does it look like to actually get models that are learning in the real world? If you look at a lot of the discourse that's happening around continual learning, it felt like there was a missing piece where people aren't talking about the same thing when they define continual learning. And two, there are not actually any evaluations for continual learning. Everyone is maybe constructing their own synthetic set of evals that if you pick any 3 papers at random, I think like with very high probability, the evaluations are completely different. And I think that, in the history of machine learning, one of the big things that pushed the field forward is we had these standardized sets of evaluations that people could get together as a community and like, yeah, this is the definition of a particular capability that we're trying to optimize for. Or maybe not the definition, but it's a good goalpost or signpost along the ways that we can all work together to optimize on this. And that just didn't exist for continual learning.
Well, let's shift topics and talk a little bit about your experience as after your second year in academia.
Yeah.
And your opinions of the state that we find ourselves in with open and closed. And also the incentive structure to stay in the PhD. What edge, what alpha is intrinsic to open research that we can leverage and lean much more aggressively into?
I think academia is definitely in a challenging time compared to what it was, say, 4 or 5 years ago in the AI space specifically. There are massive incentives for any PhD student who's doing work on maybe anything that's not completely orthogonal to language models, like anything that's on the path of language models in some way parallel, to go work at the frontier labs. And it's not just the monetary incentives, right? There's also the incentives to be able to work with the large scales of compute that you get access to at frontier labs, which academia is lacking. If you care about open research and you think that there's potential like personal benefits, but also societal benefits to that, where it's like innovation has always been faster when it's in the open. Right now, a lot of the power in AI is concentrated among the few frontier labs because it seems that whoever has the resources to compute to scale and train the largest models have been the people who are able to make a lot of the decisions or influence a lot of the decisions. It feels like intuitively to me, there are benefits to not concentrating that large amounts of power in very few people. And I think more people should play a role in that conversation. And so academia also gives you another avenue to be not fully, but a more neutral third party, at least. You're not monetarily incentivized for particular ways that you could argue a lot of the people at these labs are. And so if you can start to play a bigger role in those conversations of like what AI should look like, what does it look like for AI to be successful and actually contribute to everyone's happiness in our world? Like, what does that look like? And so if you're going to stay in academic research, then you have to make, I think, a very intentional choice to work on problems that are orthogonal to what other people are doing. And maybe this has always been true about research, but I think it's just more true now, where it's like you should be making what you think are wild or crazy bets that other people are not making. To your last point of like, are we doing that right? Maybe a bit of a hot take, but I'd say we're not in academia right now. I think that there's a lot of space for where we could be doing research that is either farther out, thinking about changes the way we think about model training or model deployment entirely.
Feels a little bit like your intuition is we're being a little too risk averse and maybe a little too FOMO oriented.
Yes.
Picking problems that feel really interesting but are like maybe a half a step ahead of where things are going instead of 2 steps ahead.
Or even on the same step or half step behind.
Sure, yeah. Like trying to play catch up.
I think that puts it exactly. I think there's a lot of FOMO in academia right now, and I think we should let go of that FOMO. Like if you're choosing the intentional decision to stay here, then we should work on whatever problems we think are coming next.
Yeah,
and
more
we'll
confidence. So that's like maybe one way to sum it up. The same kind of confidence in a sense to do something that sort of completely ignores this really exciting rocket ship that everybody seems to be boarding. So thanks for taking the bet on the non-consensus path so far.
Thank you for having me.
I hope you're still making the same bet next time we talk.
Yeah, hope so too.
Okay, you guys ready?
Let's do it.
We can pregame a little.
Give me a sip. Give me a sip.
Yeah, okay. Well, we can talk about what we're going to talk about.
Last time we pregamed, I was pretending to be Robert Nishihara.
Oh.
Do you remember that?
No. Okay, we're going to talk about Harbor mostly.
We can do that.
All right, I'm going to introduce you guys, though. Ryan Martin and Alex Shaw, thanks for joining us. You're machine learning AI researchers at Laude Institute, and you've been working in the ecosystem of evaluations and reasoning models for a while now. You both are co-leads of the Harbor open source evaluations environments framework and Terminal Bench.
So yeah, we released Terminal Bench last year, pretty much a year ago. And then one of the things that first happened is people started using it to benchmark their agents. So that was awesome because that's why we built it. But then a lot of things started to happen that we didn't plan for. So like around this time, a lot of RL environment creation companies and startups started to emerge. So this is like Scale, Surge, these types of businesses, but lots of startups that were doing that in a specific niche. And what we learned is their starting point is they would fork the Terminal Bench repo because it was a sufficiently abstract RL environment framework that they could then leverage a lot of what we had built to go start creating their own environments. And then at the same time, like people would start forking it to go create their custom agent eval in-house. People would start post-training on Terminal Bench style environments. So we looked at it and we said, hey, we didn't intentionally design for any of this behavior. And the friction becomes obvious when you start to use it for those things. So we said, let's just actually build a framework designed to address those specific use cases. And that's kind of how Harbor emerged. And since then, it's really taken off. It's now kind of become a standard in the industry where like lots of data creation companies want to sell their data to lots of different model training companies. Model training companies want to be able to buy the same type of data from a lot of different data creation companies. Agent developers are now becoming consumers of RL environments as well, as they either try to post-train their models or optimize other pieces of the stack like skills, harness, tools, stuff like that. So anyways, to wrap all of that, the way we see it right now is Francois Chalet had a good tweet the other day, which was agent development is more akin to machine learning than it is to software engineering, even though it feels a little bit like software engineering when you start doing it. But as soon as you introduce a model into the loop, all of a sudden you introduce stochasticity and a certain amount of black box behavior. And that's more like machine learning than software engineering. So I could look at an agent's implementation and I still don't know what it's going to do when I run it, which isn't true for software. That's not really how people develop software, but that is how people are starting to develop agents.
Yeah.
So what you need then is a set of tools that looks a lot like the tools people use for machine learning, but specifically designed for agents. So, your train set, your train test split, maybe that becomes environments and evals. And stuff like overfitting looks more like reward hacking, or taking a gradient descent step might look more like a PR into your repo from a coding agent or something like that. And I think Harbor plays an important role here, where it's really giving people the tools and the abstractions and structure to reason through how they're going to create tasks that represent workflows that they're trying to automate, and then go systematically figure out which agents and models can solve it so that they can optimize for like the point on the Pareto that they want to be on.
Yeah, that's a shift, right? Which is up until now, we've treated, and by we, I mean just like the ecosystem globally has treated building agents as I have an idea. An agent should manage skills, and here's a prompt. Like I declare its behavior both in code and in prompts. I'm like engineering the shape of the thing in the heart of it, which is the agent. And in this new paradigm, it's like sort of the agent is the new model, is the parallel here in the machine learning framing. And so what we're doing is we're like manipulating the parameters around them, like the evaluation, and then the agent itself, and eventually maybe even getting to a spot where the eval becomes one of the main declarative points, and almost everything else is the thing that's getting optimized by some other process. And then you get to like the more mind-blowing thing of like, can you come up with a thing like the evaluation building agent? And then what is the optimizer for the better agent, the agent that to optimize an agent that builds good evaluations?
An inception of agents at that point.
Yeah.
There's probably also, besides the agent that builds evals, I also think as soon as these agents get into production for a specific use case, then you can start pulling out things from real usage of that agent. So if the agent fails in production, then you detect that, turn that into an offline eval,
right.
And then you optimize against that, and then now that test becomes essentially a regression test.
Yeah, right. So that's this shift in paradigm. This is a pretty big, like a little bit out there. Like it's a swing. It seems like, at least at first blush, like, hey, people who are doing skills optimization, like people who are writing agent frameworks, like people building open hands or something, like your job's going to go away because there's going to be an optimizer that writes everything that's about an agent. And the only thing that really matters is your eval. And then if the next generation after evals is humans, right now it's super costly for a human to declare an evaluation and like actually do what you did. So you got nerd sniped by terminal benches, like go take experts and like get them to do the arduous task of declaring these. Can we actually make that like 10 times easier or like 100 times easier by watching the world around us and like watching the interaction points between humans and like their software tasks, their the things they're trying to use their computers for, and infer these evaluations with a lot fewer human points of interaction required. And that will be the way you scale this next paradigm. So that's like, I haven't heard anybody else talking about it this way.
I mean, I think if you think about like, if you're an agent builder, where's the highest leverage place to spend your time? It is in the evals, because the models are explicitly being built right now to be self-improving. So already the models are explicitly getting better at building harnesses, and you can also be sure that they're getting better at, Karpathy now joined, right? You can be sure they're getting better at also the model optimization. So models as optimizers themselves is clearly going to happen. So if that's going to happen, then you should be spending your time setting up the eval so the superpowered optimizer can do as much work for you as it can.
Yeah, cool. Very exciting stuff. Thanks for taking time to chat. I think that wraps us on this one. Okay, Omar Khattab, thank you for joining. You're a professor at MIT. You did your PhD with Matei at Stanford, and you have Colbert and DSPy and other successful open source projects to your name. I'd love to talk about one or two of those most recent projects. So let's start with Pedagogical RL. What is it? And how does it work?
Sure. So if you think about the paradigm of reinforcement learning, this has been like the driver of progress for the last couple of years. It has been actually a pretty simple approach, which is you take your current model, which you've trained for a long time, a lot of pre-training and whatnot, and then you basically put it in environments, get it to act, and then look sort of retrospectively at those actions, at the trajectory that it took to arrive at some answer usually that it generates or a response it produces, and then basically you observe a reward. Maybe the answer was correct, or maybe the code the model wrote sort of passes tests, or maybe the answer to a math question matches the answer that we expect. And basically the idea is, in the cases where the model ends up arriving at the right answer, we amplify the probabilities of the actions it took. And in the cases where the model does the wrong thing, well, we push those probabilities down. And we hope that if we do this for long enough, the model basically learns to act in those environments, and we get improved general intelligence. But there has kind of been a weird bottleneck here, which is a lot of the time we want to teach the models harder stuff. A lot of the time, the way you teach yourself a hard subject is not that you just keep trying and observe rewards. Is sometimes you actually, maybe you try a couple of times to solve a hard math problem, and then you actually take a peek at the answer. And by looking at the question and the answer, you sort of try to find what would a path that I could have taken look like, so that I could actually try to solve problems like this in the future. So pedagogical RL says, let's actually train the model as a self-teacher. Let's take the questions, and then whatever information already exists in the environment that would typically be used in this reward calculation in order to do standard policy gradient RL, and let's actually give both to the model itself and say, hey, here's a question, here's a hint about the answer or the way you would have evaluated the answer or the final destination that you would arrive at. And why don't you just actually try to solve the problem now that you know where the destination is? Now, if you just do that, this is not new, and it would not work very well. And one of the reasons is it's really hard for models, as it is for people, to basically not just simply jump steps, because I know exactly where I want to go. If you give me a hard math problem and you tell me the answer is 10, well, I'm going to it's going to be really hard for me to keep myself honest and in check in every part of my reasoning steps.
Right.
But the beautiful thing is that for models, it's actually pretty quantifiable what a reasonable and realistic trajectory looks like, because we can actually go to the model itself and hide the hint or hide the answer and basically estimate whether any given step in a particular reasoning trace, whether that step is something that the model would assign a non-trivial reasonable probability to.
That's just the perplexity at that step.
That's just essentially the likelihood that the model would assign. And what this means is that we can actually take our really hard reinforcement learning problem, where you keep trying, your model keeps trying, and it cannot even answer any of the questions in your data set because it's beyond its capability level, and turn it into a much more interesting and dense reward environment where your model sees the question and the answer. So it's actually arriving at the right answer disproportionately often, because it can easily at least cheat. And now the way we distinguish good rewards, good rollouts or good trajectories and bad trajectories is based on how many unreasonable jumps they have, essentially, or basically
how often they sort of cheated, whether they let knowing the answer was 10 cause them to take a shortcut in their reasoning stuff.
Right, exactly. And because this is so measurable, we can actually use the standard RL algorithms of sampling from the model that has the ability to condition on these two things and reinforce its behavior. The more it arrives at successful answers through fewer and fewer shortcuts or through more reasonable reasoning, we can actually reward it for doing that. And what we achieve this way is a really good self-teacher.
That's pretty amazing. And it works.
And it works, yeah. So this gives you a really good self-teacher. But the nice thing is, whenever you could apply reinforcement learning before, or JEPA for that matter, we know that you've had a data set or a source of questions and essentially whatever it is that you use to evaluate the answers. Now that you have those, you can condition on them, use the self-teacher to sample these trajectories that work really well, and simply transfer them to a student with basic distillation. You could basically just train a model on them. And now the model is able to acquire what should I do in a given state from a really good teacher. It's almost as if you had a much better model that could teach it, but that model is also aware of the reasoning capacity of the student.
Where does it go from here?
And our hope is that as you begin to push to this paradigm of models learning to teach themselves, a much larger space of learning algorithms, I think, becomes accessible.
Yeah, very exciting. Can't wait to see where it goes from here. Okay, well, thanks for stopping by.
Thanks, Andy.
What are we going to talk about?
You're happy.
That's the first question. What would you like to talk most about today?
Do you want to retell the story? You want to?
Yeah, we can tell the story. So I have Dave Patterson here, who is a professor at Berkeley for 40 years, won the Turing Award with John Hennessy for RISC, the RISC processor. Also had Angelina Jolie call out to RISC in one of my favorite movies and a
Turing
formative
Award,
movie for
Angelina
me.
Jolie, they're right up
Hackers. So since retiring from Berkeley, spent nearly 10 years at Google working on things adjacent to AI. And you've teamed up with me and Laude in the last 2 years to work on a Moonshots grant program. So you've long distinguished career, also co-author of the textbook on architecture, and you're an architecture by background in your research area. What did I miss in your bio?
No, you've got pretty much.
Got the highlights?
Yeah.
Okay. Thanks for chatting on camera, and cheers.
Cheers.
To a great day. Maybe hide our labels like they do in Hollywood unless they pay us. Tell me about the moonshots.
Well, when we were writing the Shaping AI paper that Andy suggested we do and bring together a really strong team of co-authors, as part of that process to get AI researchers to do projects that help the public, raising the upsides of AI and reducing the downsides, we thought it'd be interesting to identify some moonshots for the AI researchers to shoot at. And one of them, like, which one we should pick, and then we talked it over with AI. You could do a lot. And so we picked 4.
What are the 4 that we landed on?
It was health, improving healthcare, accelerating science, when people lose their jobs, to reskill them to get other jobs, and then improving civic discourse. And then last Thanksgiving, we put out a call for papers to see who would respond. We really didn't know what would happen, and we were thrilled to get 125 proposals from all the top institutions in North America. And we got an overwhelmingly response, not only in numbers, but in quality. We had a world-class program committee evaluating them, including Turing laureates and a Nobel laureate. I think everyone mentioned, well, these are much more interesting proposals than we've seen in the past. By getting people to raise their sights to try and shoot for the moon, they did more ambitious things that might have even greater impact. So, we're trying this new path, and it shows some signs of being different from what's been done in the past in a very positive way.
And you skipped the part where we first met at Schmidt's Pub in Berkeley and had the idea together, where we had Guinness.
I'd say you had the idea.
I pitched you on an idea, and what we decided that day is pretty close to what we've done. And we also had beer that day, so here we are having beer again. That's why 2 years later.
That's why we're refreshing ourselves with beer. Yeah, you wanted to get more people to have the experience you had as a grad student in one of these Berkeley-style labs. High impact was the main goal. Papers were secondary, and that AI was this opportunity for us to target. And back when you were a grad student, we wrote this visionary paper about cloud computing, which was controversial at the time. You thought we could do it again, and we've kind of exceeded expectations. We wrote a technical report that was widely read.
And that had a lot of famous authors on it.
Yeah, we had John Hennessy,
Jeff Dean,
Tino Cuellar. We interviewed Obama and
John Jumper, who just got who won the Nobel Prize right after we interviewed him, or right before? I can't remember. Right after.
And we wrote a paper. It was reprinted or revised in the Communications ACM on the cover of that.
And you had like a little piece in The Economist, too, about it.
That's right, to try to get the word out. But we had a bunch of goals, which is, be in a popular magazine, get an influential paper, get it published, be it out there, get a strong committee, interview a lot of people, and then go on from the moonshots to try and get people to work on the moonshots. And I think in kind of every target, we've exceeded expectations.
And now we're on to the fundraising one.
And now we've launched 25 different groups. We've given them seed grants, and they're supposed to come back in 6 months to show progress. And we're going to be trying to get philanthropists to donate money to fund these 3-year, $10 million labs, and we're on this adventure to see how well we're going to be at philanthropic fundraising.
And in the meantime, since I've written the first check, you wrote the second check.
Yes,
And we're
that's right.
lining up the third and fourth checks coming in from
That's
other successful technologists who are distinguished in their careers and have been lucky enough to benefit from the impact of the systems that we build in the world. And that's a theme here.
As young as I think I am, I still have got 50 years in the field. So I feel those of us who have been around a while, it's up to us to preserve the opportunities for this next generation. And I think those of us who can afford it ought to, not just set an example by caring about the issue, but by donating some of our wealth like you have. And so I'm hoping several people who are famous for their contributions to computing and AI will also support Laude with their paychecks.
Yeah, well, thank you for doing it yourself.
The one thing I can say about AI, it's unaffordable to everybody. I mean, there's a space race, so people are spending hundreds of billions of dollars. Google, Microsoft, Amazon, and Meta this year are going to spend more than $700 billion in CapEx to data centers and chips because there's a competition and they're afraid to be left behind and they're first. But it's not because, wow, we'll spend $700 billion this year and we'll get this huge return, right afterwards, right? When I think about it in my personal history, those same tremendous costs, you could argue, were true for computer architecture, microprocessor design. Intel and companies like that, where they would spend $100 million designing a microprocessor when people at Berkeley and Stanford were trying to design microprocessors. So, if we did exactly the same thing that they did, we couldn't win, but we came up with a different set of ideas and were able to take advantage of government funding to build prototypes of the ideas. They weren't products that you could ship, but the prototypes were so convincing that commercial companies followed in the wake of that, and the RISC architecture became very popular. So we need great ideas that make AI much more affordable. I think we've proven that it's valuable. Everybody wants to use it. So if academia with a lack of money can demonstrate how to get some of these same quality ideas much more economically, that'll be, award-winning research. That'll be something people will beat a path to the door.
And even research that the big players would have incentives to fund, potentially.
I'm a chip designer. I still want it to be more affordable. I like people to use my chips, but if we could get a breakthrough, and if we had 10 times the compute today, they have great ideas how to use it. So could we make computing a factor of order of magnitude more cost effective for AI? That would be a huge boon. But I think it takes conferences like this will help figure out what's the roles each can play to their best use.
And you were distinctive in your approach, especially 20, 30 years ago, in bringing industry into the lab every 6 months to give feedback and inform artifacts that the labs would build that were prototypes and proofs of concept of potential impact, what could become technology transfer. You created a lot of fertile ground for that tech transfer. I think a thing worth talking about briefly here at the end is how does it feel like it's going as we encourage in research labs across all the top universities outside of Berkeley, outside of your direct legacy, to do similar things as we talk about funding them with the Moonshot grant program?
It was, to me, it was just common sense. The people in the industry went to our former students, right? They're not aliens from another world. They're smart people, and they've got lots of experiences different than yours. And if the ultimate goal is eventually for people to use your ideas in this industrial world, why not take advantage of the opportunity to have them and give you feedback along the way? It's just hugely beneficial. There's this interesting kind of alternative universe. What's the legacy? If we look back 5 or 10 years with the legacy moonshot program, it might not be the people we fund. It might be by setting the moonshots and getting these people to cross disciplines and work together and come up with a provocative idea. That might end up being what the contribution of the Moonshot program is.
Yeah, right.
And that would be a very exciting legacy if that's true.
Great. Well, that's a good spot to end, because I think what better time to be a researcher and do a moonshot than when maybe the technology's there to let you have species level impact.
You want to be a researcher at a time when there's exciting opportunity. When things are slowly changing and making lots of money and not innovating, that's not a time to be a researcher. This is an amazingly good time to be a researcher.
Well, here to the grand experiment we're running to make sure it goes the right way.
Okay.
All right. Thanks, Dave.
All right.
We have Swix here with us at Laudecast.
Thank you for having me.
You're welcome. Thank you for joining us. Swix, I read your newsletter and I read Alex Heath's newsletter, and those are the two that I read, and that's all you need. So thank you for making such a high quality newsletter. Okay, special thing. First, fortune cookies. Oh, these are real fortune cookies. We're going to tell each other our fortunes.
If you don't like your fortune, you can re-roll, yeah.
Re-roll, okay. We can trade too, if yours is more appropriate for me. Like, your beard will continue to be prosperous.
No, I don't have a beard, yeah. All right, you go, I go?
You go.
You will ship your research. That's nice.
You will open the frontier.
Wow. Okay, that's solid. That's really insanely good.
Maybe we both will ship research and open frontier.
I don't do as much research. I do like meta research, right? Like the whole, like, I am the reward model.
I thought I wanted to be the reward model. I was jealous of you for a chapter.
Aren't you?
Aren't I still jealous? A little bit.
No. No, I don't think you have anything to be jealous about.
It's a nice scarf, at least.
Thank you for giving it to me. I think you are a reward model in some respects. Everything you do.
That's true. I do literally give money away
Yes.
to people that do a good job at shipping their research. So you've nailed the newsletter and a 6,000 person conference and growing.
Yeah.
What's the next frontier?
That's interesting. Okay. I recently discovered that the kind of conference that I run, that we run here, that we're at, these are called what they call festivals, sort of like very content-driven, knowledge-driven, all that stuff. 5 times larger than that business is the data markets business that they run. So I'm suddenly very interested in data markets. It might be phase 2. I never signed up to be like a conference guy. I think I just like... to me, when I
just stumbled upon a 6,000 person.
The eventual vision is to be industry NeurIPS. As much as NeurIPS' atomic unit is the paper and like the grad students, and it's a meat market for hiring grad students. Like sort of research has moved from industry to sort of production or deployment or whatever, and it should have something of equal stature to that. NeurIPS is a 40-year-old conference. I think we can get there in 10.
That's great. I like that. So. I was talking to Parth around earlier about the grad student experience. I also talked to Joy Gonzalez earlier today. The thing that's been dawning on me a little bit today is that when I was a PhD in 2007 to 2013, when we started Databricks, there was this underdog white space. There was this underdog opportunity to double down on research that ships, as we say it now. But today I've been like it's occurring to me this next layer of the onion, which is, can you, instead of seeing it as just market cap and product, in the world of AI, where AI as a technology is rewriting pillars of society, like education, like academia itself, like civic discourse. And I think AI is going to be a whole nother turn of the crank on that. And so now the word that I've been using, and I don't know if it's the right word for it, is power. It's just like political power. Money is hard power, but you can also have influence. People have power and they move from one lab to the next, which is the whole thing right now, right? Like people are like flittering around a year at each of the top. They're just like rotating across the top 3 labs every 6 months.
Publication by diffusion.
Yeah, exactly. So there's this new thing that researchers aren't just the greatest at going and having impact by building companies. They're actually also the greatest at going and changing the world through impact by other power mechanisms. I mean, I knew one of the power through building a billion-dollar company or $10 billion, $100 billion company. Now I know that kind of power. But power to influence the way that my kid's future is going to play out with the education system, that one is like kind of new to me. And I'm starting to see that researchers have the potential to be the most some of the most powerful people on the planet. And I think we need to wake up and pave that path the way that I've really tried to beat the drum for paving the path to doing big companies. Because I also believe they happen to be the most promising candidates. If I had to pick a type of persona to sort of bet my daughter's futures on, now I'm biased, I would make it AI researchers. Does that resonate with you?
Yes, it does resonate. I would say the one place where I start to disagree maybe or diverge from you is the relative role of the researcher versus the engineer. Every great researcher needs like an army of small little products engineers, platform engineers, research engineers to enable the researcher to do what they do. Otherwise, they would just not be nowhere near as effective.
Oh, yeah. We should have like a engineer versus researcher showdown. Questions from the audience. Parth, we're talking about power.
I mean, you pointed out the example of AI researchers going to different labs and like publication by diffusion as an example of soft power. I was thinking of it a little more broadly too, though. You said AI researchers should be the people with the soft power. And I'm just curious if you think that's a generally true statement. As then, why do you think that's a bad idea for when it happens in the labs? Do you think it just shouldn't be concentrated, or?
Well, if I had to pick the closed labs versus, I don't know, the oil industry to have all the power, I would pick Anthropic. If I had to pick not a concentration of power over a concentration of power, I would pick not a concentration of power. I think the oil industry is kind of an apt like parallel here to a lot of concentration into an industry that at the time had done something that it gave a lot of leverage to humanity, and they had like a concentration of control over that resource for humanity. And so engineered intelligence is the current one. Yeah, I mean, that's my read on it. I agree with a lot of things. I agree with Dario on a lot of things. And one that I vehemently disagree with him on is that it's too dangerous to just do things in the open. I think it can be dangerous to do. It is dangerous if you just patently say everything has to be open. There are clearly like lines you have to draw. But the Anthropic line so far, at least in the behavior that they manifest, is like it's anti-open. And that's where I strongly disagree.
What is the way through which we're going to move away from the concentration of power in the few frontier labs that we have right now?
How do we defend democracy in the context of AI?
Yeah, where we're supposed to trust the objective functions of a few people that I don't necessarily see a strong reason to do so.
Yeah, break the scaling laws. You're on it.
Break the scaling laws.
Because like the bitter lesson necessarily concludes in the concentration of power right now.
Yeah, it does.
You know, scaling laws are king. If you can bend them, you win. If not, then the existing powers get bigger.
Okay, second question.
Okay, yeah,
Melissa.
Thanks for the interesting talk. I guess like back to like the topic of conference and paper a little bit. Like, what do you think is like the role of peer review conference right now? How do we define the impact of paper now in like this world where like things are moving super fast?
Yeah, so actually I've been pitching a bunch of academics, zero peer review or complete AI peer review, like take the human out of the loop. And everyone has been like kind of positive.
Positive response, you mean?
Yes.
What's the rationale?
Because humans are very arbitrary and bad and lazy.
At peer review.
Yes. Again, scaling laws. The number of submissions are going like this. The number of reviewers are going like this. Like, it's broken. The whole thing is broken.
What about using AI for the first few rounds and then still using humans at the last
layer one,
round?
layer two, yeah. Absolutely, right?
Third question.
But this is actually more of a Swix question. So, okay, we did this thing. There's a bunch of peer-reviewed papers that are going to end up at the AI Engineering World Fair. Cool. What would be the ideal outcome for sort of like this research arm of the AI Engineering World Fair?
I just want good ideas to spread regardless of what format they're presented in. I think that a lot of the people in the industry that would want to hear the ideas that are presented here will never come here.
Yep.
So let's bring the researchers to where they are, where I am.
Yep.
So if I can provide a venue for that, and most conferences in the industry do not, then I should, and I must. So
we just got to get it out there.
Yeah.
Okay, is that it? We're a wrap. Thank you so much.
Thank you so much. It was always a pleasure.
Yeah. Thanks for joining Laudecast at the Compound AI Systems Conference by ACM. I'll keep putting microphones in front of the best minds shaping AI and pushing the open frontier, and I'll see you next time.